So we will continue our discussion on the detergent. Last time, we have seen basic structure of the soapy and soapless detergent. We can say both of them contain the hydrophobic tail and the hydrophilic head. Today, we will see how the detergent works on the cleansing. Now the first one is the detergent acts as a wetting agent. Now this is because most dirt trapped on the fibers, and if they cannot soluble in water, so the water molecule cannot bring the dirt away. However, because there is high surface tension for the water molecules, okay, so maybe you can record it in the unit 24. We have mentioned there is strong hydrogen bond between molecules. That means the water molecule tend to attract to each other to form a surface rather than spread out. If water exists as a droplet, then the dirt may not able to dissolve in it. So the function of detergent is try to reduce the water surface tension. That means they will spread out on the fiber rather than become a water droplet. The second one is the water acts as a emulsifying agent. Now this is more important, so please highlight this. Now let's study the following case. Without any detergent, oil and water cannot mix together. They will separate into two layers. Well, I think we have familiar with that already. After shaking, the oil will become droplet, but soon the oil droplet will merge together again to form a oil layer. This is the situation when there is no detergent. However, when there is a detergent inside, take this picture as an example. The hydrophobic tail, or we can say the nonpolar tail or organic tail, will try to dissolve in the oil layer because they have similar intermolecular force strength, while the ionic head will try to stay in the aqueous layer. Because the ionic head carries charge, they will try to spread as much as possible. So this is the case before the shaking. Oil layer becomes small after shaking, oil droplet you can see, and this hydrocarbon tail still trapped inside. However, because the oil droplet has larger surface area, that means the ionic head will try to spread out and cover the whole oil droplet surface. Now, you can see the whole surface of the oil droplet carry negative charge. That means they will repel from each other, or you can say they tend not to merge again. This emulsion is more stable and with larger surface and the negative charge on the surface, the oil droplet can be washed away by water easier. Now let's try to fill in the blanks. First, the detergent has a hydrocarbon tail. In our example, CH3 bracket CH2 10 CH2, and the ionic head is COO minus. So again, be careful. The sodium ion is not included in the ionic head. The head is hydrophilic and the tail is hydrophobic. Okay. Upon shaking, the oil does break down into oil droplets, and the ionic head on the droplet repel each other and suspended in the water. We call this process emulsification. And finally, the tiny droplet can be washed away easily. Okay, so again, this 4 sentence is very important because it tries to elaborate how the detergent functions. I hope all of you can memorize and express it right out in your own sentence. But of course, some vocabulary cannot be omitted, right? For example, hydrophilic head, hydrophobic tail, ionic head, whatever. Okay, let's check the checkpoints. The first one, the structure of detergent is shown here. So which sentence is correct? The hydrocarbon tail, is it this one? Well, the answer is no, because the hydrocarbon tail should not include the ionic head. The second one is the hydrocarbon chain is hydrophilic. So again, I think all of you can figure out this is something wrong. C, it reacts with grease by chemical reaction to form soluble products. Well, the answer is yes or no? No. Okay, let's check again why this is no. Let's review D first. It acts as a wetting agent to reduce surface tension of water. Okay, this is correct. So the answer is D, no problem. But what's wrong with sentence C? Okay, I think this is the most difficult part in this question. So spend a few seconds to figure out what's wrong with sentence C. Yeah, I think some of you get the answer already. It should not be a chemical reaction. It only dissolves in the grease. Again, the dissolving of detergent in the grease is a physical process because no new substance is formed. Okay? Okay, question 2. So again, please spend a few seconds. So let's see, a good cleaning power. So any criteria for a good cleaning power? Maybe you can figure out. Yes, we have carbon chain and a ionic head. Good. So among all these 4 choices, C is not correct because we don't have any ionic head here. Okay. The second one is A should not be the answer because the carbon chain in A is too short. If there is short carbon chain, that means the non-polar properties is not very large. They tend not to dissolve in the oil layer, and this will reduce the cleaning power. Okay? Only boy and dog remains. So which one will be the answer? And we need to check the questions again. The question mentioned this should be a soapy detergent. So boy will be the answer because SO3 should not be a soapy detergent. Okay? Now, question 3. Which of the following compound can be used as active ingredient for the detergent? Now, again, what should be the active ingredient? It should be contain ionic head and covalent tail or non-polar tail. So among all these 3 compounds, all of them are possible. So D, 1, 2, and 3, because all of them fulfill our idea. Next, we're going to discuss how the soap and soapness detergent be prepared. Okay? Now, I will try to move to the soapness detergent first because this is a simpler case. The soapness detergent is made from hydrocarbon, or you can say is from petroleum. In most cases, they will react with sulfuric acid, and that's it. Okay? So all you need to memorize is soapness detergent comes from petroleum. How about soapy detergent? The soapy detergent is made from fat and oil. Okay? Now, let's see what is fat. Okay? Maybe in the biology lessons, you have ever heard this term, fatty acid. So what is this? Well, actually, fat is something we call triester. Okay, you can see in this molecule, we have 1, 2, and 3 ester functional group. Okay, that's why the molecule is triester, and this is the fat or oil. During the process, we try to use alkaline solution to break down this ester, or you can say this is an alkaline hydrolysis of ester. In alkaline condition, the carboxylate ion rather than carboxylic acid will be formed. there is also an alcohol, but this time it is a molecule containing 3 OH group. The name is propane 1,2,3 triol, or it has a common name called gasoil. So let's see how it works. First, we try to heat the oil or fat with sodium hydroxide solution. Okay, again, this process of making soap is very important. Again, please memorize and write it in your own sentence. Okay, we mix oil and fat and sodium hydroxide and heat it. Well, this process we have a special name called saponification. Okay, yes, in the examinations, if you fail to spell this word, you can say alkaline hydrolysis of ester. Okay, but personally, I recommend you to spell the word saponification. And after breakdown process, we have the gasoil and soapy detergent mixed together. So how can we separate them? But the answer is we need to add concentrate sodium chloride solution to sort out the soap. Now this process we call sorting out. Again, this term is so special that you must spell it, okay? Because you cannot have other word to replace it. Now, because we found that sodium chloride can reduce or lower down the solubility of the soapy detergent, okay? So, if there is concentrate sodium chloride solution added to the mixture, then the soapy detergent will exist as solid form, and then good, we can filter the soap from the solution by using filtration. Easy, okay? Now, so let's see how to express this idea with chemical equation. The first one is, now here you are always given the chemical formula of the fat, okay? Don't worry, and no need to memorize, okay? As usual, we try to break down the CO single bond in order to simplify our reactions. So we just copy the alcohol part here. This is the alcohol part, and of course, extra H will be given from the solutions, okay? Now this is our gasoil. And how about the carboxylate part? Carboxylate part will be, okay, we direct copy the given information, 16CH2, 1CH3, and again, the extra O minus will be given because this time we have sodium ion. Like this. This is the sodium salt of our carboxylic acid. But you should be careful because here we use 3 sodium hydroxide and 3 carboxylate salt should be exist in our product. Okay, so this one is gasoil and this one is soapy detergent. Okay, like this. So not only write down the chemical equation, but also you need to emphasize the coefficients. Okay, like this. Okay, so let's see the checkpoint again. First, which of the following substance is not from the petroleum? And I think you get the answer already. It should be soap, because soap is come from oil or fat. It is none of the business about the petroleum. The second one, so have a look. About soapless detergent is correct. Yes, first, no matter this is a soapless or soapy detergent, both of them have hydrophilic head and hydrophobic tail. So this one should be correct. And the second one, I think you get the answer. Sure, correct. They come from petroleum. And the third one is it possible to form a stable emulsion when added to the oil-water mixture? Well, the answer is yes, because they can form stable oil droplet exist in the water layer. Okay, so this is a stable emulsion. So our answer will be D. And question 3, X should be okay, sure, X will not be A because there should be one A formed. Okay, so A should be Y in our expression and won't be C or D because C is an ester and D is a carboxylic acid. They should not appear in the alkaline medium. So the answer is boy. Okay, and question 4. When peanut oil is heated with sodium hydroxide, so what will be formed? So 1 is correct, 2 is correct. How about 3? Is it triester will form? The answer is no, because triester is the oil or fat. It should not appear after heated with sodium hydroxide. So the answer is 1 and 2 only. Now next one, question 5. So here shows the preparation step of soap in the laboratory. So part A is very simple. Name the type of reaction. So what is the name for this reaction? This is a term that I just introduced to you and hope you can spell it. Yes, this is saponification. Part B, you are given the structure of the oil, so what will be the chemical equation? Yes, we copy the reactant first. Okay, let's see. In our experiment, we use sodium hydroxide solution. Okay, so we add 3 sodium hydroxide here. And how about our product? Yeah, for safety, I try to copy everything as much as possible to prevent any typo. Sorry, so you can see typo exists. Yes, this one should be H, a trial, and this one is a sodium salt. But again, sorry, we have 3 sodium salt here, so this will be the chemical equation. Part C suggests one safety precaution when handling concentrate sodium hydroxide solution, which is strongly alkaline, so this is corrosive. We should wear gloves when handling it. Part D. In step 4, we add concentrate sodium chloride solution. So what is the function for the sodium chloride solution is try to sorting out the soap. Or you can say it's reduce the solubility of soap. Now, in step 7, a small amount of distilled water. So let's see what the experiment carries on. After filter the mixture, we wash the soap with a small amount of distilled water. Okay, so what is the purpose for that? So the soap we just formed is highly alkaline because we use sodium hydroxide to prepare. So of course there will be small amount of unreacted sodium hydroxide stick on our soap. Okay, that's why we cannot use it immediately. So small amount of distilled water is used to wash or remove the unreacted sodium hydroxide on soap surface. Okay, and okay, let's see what is the hydrophilic part and hydrophobic part. I think this is easy for you, right? So spend some time to draw it first. So let's check. The hydrophilic part should be the red circle, and the hydrophobic part should be the green circle. So let's write it down. This is the hydrophobic part, and this is the hydrophilic part. Okay? Okay, for part G, we will leave it for a few minutes, and let's see the disadvantage or advantage of using different type of detergents. Okay, now back to our discussion on the problem of using soap and soapness detergent. So everything have its pros and cons. So let's see. Now the basic problem is for the soapy detergent, it is come from natural. We use oil or fat to make it. Okay, so it is totally biodegradable, no problem. But how about those soapness detergent? Okay, so this problem mainly found in soapness one. Okay, some soapness detergent is non-biodegradable. So why? Let's have a look on this picture. Here shows a typical example, and we can say, besides the long carbon chain, there exists some branch here. You can see here are 3 branches. Okay, and with the branches, this will affect the enzyme action to break down the detergent. As the result, this detergent will form a white foam in the sea or the river. It causes another type of pollution. So in order to ensure the detergent will be biodegradable, all branches should be removed. Okay, so maybe you can see, write it down, is no branch will make it biodegradable. Okay, the next problem is, okay, now we understand we should produce some detergent without any branch, but this is not the end of the problem. Okay, even though the detergent is biodegradable, if there are too much detergent discharged to the river, okay, we need many microorganisms to digest it or break it down. And while the microorganism works, they will consume the dissolved oxygen in water. As a result, because the dissolved oxygen in water is used up by the microorganisms, and the other organisms in the water or any marine life will die because they don't have any oxygen supply. Okay, the third one, okay, it seems soapy detergent will be better because it comes from naturals, right? But there is some problem associated with soapy detergent only. that is in the sea water, or we can say in the hard water. So let's see. Hard water, what is meant by hard water? Hard water is a water that contains large amount of calcium ion or magnesium ion. Well, there are two typical examples for the hard water. The first one, as I mentioned, is the sea water. Okay? You cannot use the soap in the sea. The second one is those mineral water. Okay? The water contains many minerals. For example, in many countries, okay, they will consume mineral water. So, the problem is, with the long hydrocarbon chain, the soapy detergent is actually not very soluble. Yes, it is soluble because it is a group 1 salt, right? All group 1 compounds are soluble, but the solubility is not very high. Now, they will react with the magnesium ion or calcium ion to form insoluble salt. Now, so what's wrong with the insoluble salt? So you can see, with combine the calcium or magnesium ion, so our soapy detergent now become not mobile. They are not mobile ion anymore, and that means we need extra amount of soapy detergent to finish our cleansing task. Or we can say the soap will be reduced in efficiency because we want more and more to compensate the one formed insoluble salt. In chemistry, we have a special term for this insoluble salt. We call them scum. Okay? And so how do people live in the hard water region solve the problem? They will add some phosphate in their water. This is something we call water softener. The major component is phosphate ion, but the phosphate ion not only combine with the magnesium ion or calcium ion. Okay, after they combine, the hard water becomes soft water, then the people can use soapy detergent. But the problem is, after you finish the bath, the phosphate will be discharged into the river or into the sea. And don't forget, phosphates are the nutrient for the plants. So if many phosphates is discharged into the sea, then the plants will be very happy because they get plenty of nutrient, especially for those algae. So this is what we call the algae boom. Okay, there's a typo here. ALGAE, algae boom. Okay, the algae will grow very, very fast, and then they will block the sunlight and make the plants underwater cannot perform the photosynthesis because there is no sunlight penetrate inside. As a result, they will die. And the story happened again. The plants underwater will die, and the microorganism will try to digest it or decompose it and further consume the amount of oxygen in water. And again, those marine life will suffer on that. Okay, that's why we should not discharge too many phosphate ion into the sea. Okay, so that is the problem associated with the use of detergent. Okay, and in this video, okay, have a quick revision. We have ever discussed how the soapy detergent is made from fat and oil, and this process is called saponification, and there is a special process inside called sorting out to reduce the solubility of soap. Then we have a short paragraph on the soapless detergent. This is made from the petroleum. And finally, we have discussed the pros and cons of using detergents. Okay, so in next video, we are going to discuss another chemicals in our daily life.